we'll often also come across some more difficult problems in trigonometry that might be a little bit harder to work out how to begin, and this one is an example of that. So in this particular shape, I'm told these angles in here, and I need to find this side, this right hand side. This question was actually taken from an example where this was someone standing on top of a building of a known height of 66 meters, and they were measuring the angle of inclination up to the top of this other building here and the angle of depression down to the bottom, and then trying to determine the building's height from that. So we need to be able to determine this height somehow, and we can use our trigonometry to do that. If you haven't had a crack at this problem already, have a go now, see if you can work it out, and then I'll step through my solution. Okay, I would start this problem by, I guess, trying to apply this measurement to something over this side. So because of the nature of this shape, this height here, 66 meters, is the same as the distance from here to the bottom here. So this distance here has to be 66. So if we can determine the height of this little bit here, which I'm just going to call h for the moment, just to have another letter, we will be able to get x by adding 66 to h. Okay, so the question is, how can I get this height here? Well, that height there is related to this top triangle. And the problem is I don't have any information about that triangle yet. So I've got to work out a good way of determining some of that information. And the best way to do that is actually to get the length of this side here, because that side there is also shared with this larger triangle. So I'm going to give that a name as well. I'll call that A. So to start off, we'll be considering this bottom triangle. I'm working with this angle here. This is the adjacent side. And this here is the opposite side. And I know that this opposite side is 66. So opposite and adjacent, that's going to be tan that I'm going to be working with. So tan of 51 degrees, let's work out what that is. 51 tan is 1.235 approximately. So in other words, the opposite over the adjacent, 66 over A, has to be this number. So I need to make A the subject. If I multiply A up to this side and then divide by 1.235, five's not very clear. That'll give me the value of A. Let's do that. 66 divided by 1.235. I get a value of 53.44 for A. So let's look back at our diagram and make sure we're sorted on what this is telling us. So this distance along the bottom here is 53.44. So now I'm dealing with this top triangle, and I can find the value of h along this side. Again, opposite and adjacent, I'm going to be working with another tan question. So h on 53.44, and actually I'll move that over just a little bit because I want to have a bit of space on the left hand side. Working with tan, I said, so tan of 34 has to be equal to h on 53.44. Again, I've got an equation. I need to solve for h this time. I'm going to work out what tan 34 is. This number here. .675 is equal to h on 53.44. Solving for h, multiply by 53.44. let's work out what that is. And I get h as 36.05. Alright, so we know that h is 36.05. Oh, my eraser's not working. There we go. What did I say it was? 36.05. So the total distance x is found by going h plus 66, those two things added together. Let's add that on. And I'm going to get 102.05. And depending on the question, reasonably I could probably just round this off to 102 meters as being the answer to this question.